Hey, boys and girls, welcome back to another edition of Crush Lusher Television. Okay, we are going to knock out 2017, pretty recent, number six. This means no calculator, so we got a bunch of stuff going on. So let's check it out. This is one you should probably try and do yourself, and then check your answers as you see me do it, and then redo anything that you got wrong to make sure you can get it right when it counts on May 12th coming up. Nice job. Okay, so we got this table with G and G prime, okay. Then we got H right here, all right, and then we got F. So we have three functions. We have G, H, and F. G is differentiable, and the table gives the values of G and its derivative G prime at selected values. And H, be the function of the graph consisting of 5 line segments, is shown in the figure above. Okay, so then you got A, B, C, D. So you got 4 parts to this. All right, let's see if you can do it. All right, unpause it. See if I can do it now. Find the slope of the line tangent to the graph of f at x equals pi. Okay, so here's f. So I gotta make sure I get my stuff right. Here's f. This is g. This is h. So f. I'm talking about this just for part A. Other parts are relevant. So you need to find the slope of the tangent line. So I need to find the derivative of this and plug in pi. That's what it's saying. Alrighty then. Let's do it. Do. Hey, how y'all doing? Let's get my stuff going. Here we go. So, f prime of x equals cosine of 2x. So this part's going to be a chain rule. So sine, cosine, negative cosine. So derivative of cosine is negative sine. So I got negative sine, keep the inside, times derivative of the inside. Derivative of 2x is 2. Cool. Plus. Now to find the derivative of this function, so e function, you always just copy it down first, times derivative of the exponent. Derivative of the exponent, derivative of sine is cosine of x. Cool. All right, so now I got to plug in pi like that equals negative sine 2 pi times 2 plus e to the sine of pi times cosine of pi. All right, so let's remember our unit circle. So here is 0 or 2 pi. And so this is going to be 1, 0 is the point there. And at pi over here, this point is negative 1, 0. And so cosine is the x and sine is the y. X, y. So sine of 2 pi would be the y coordinate here. So that would be 0. So this whole thing is 0 right here. So this is 0. This whole thing, 0. Plus sine of pi, so pi, that would be the y coordinate here is 0. So e to the 0 times cosine of pi. Cosine of pi is negative 1. Bam. So e to the 0 is just 1 and times negative 1. So 0 plus 1 times negative 1. 1 times negative 1 is negative 1 plus 0 is negative 1. Cool. So f prime of pi equals negative 1. Got it. All right, let's keep moving on. We got part B. All right, here we go. Let k be the function defined as k of x equals h of f of x. All right, so now I'm finding k prime of pi. Okay. So I wrote it down right there. So I want k prime of pi. This is k. So I have two of those functions. It's a composite function. So I got to find k prime of x first. So find the derivative first. This looks like another chain rule. Yeah. So keep the outside. Sorry, derivative of the outside. Keep the inside. Times derivative of the inside, which is f prime of x. Cool. All right. So now I'm going to plug in pi. So k prime of pi is h prime of f of pi times f prime of pi. All right, so we know f prime of pi. We just did that. This is -1 right there, so we good. So I got to figure this out. So f of pi. So if f is this, so I just got to plug in pi there. And then figure out what the derivative is at that point. Okay, so f of pi straight up is going to be cosine of 2 pi plus e to the sine of pi. Okay, so cosine of 2 pi, that would be this. The x coordinate at, no, 2 pi, my bad, would be 1. Because 2 pi goes all the way here. So 2 pi is this, so that would be 1. Plus e to the sine pi. So sine of pi is 0, so it's e to the 0. So it's 1 plus 1, which is 2. All right. So now this equals h prime of 2 times -1, and we got that from part A, f prime of pi. So h prime of 2, so that means the derivative or the slope at 2 of h. So let's look what we got. So where is 2? Here's h, so here's 2 right here. So what is this slope at 2? So that would be down 1, right, 3. So that's -1/3. That's the part, that's the slope at h of 2. Okay, so it's -1/3. Got it. So I'm looking at that. I got -1/3. Let's see. So this is -1/3 times -1, which is just 1/3. Cool. So that is the final answer. That's k prime of pi. Bam. All right, part C. Keep it going. Part C. Let's rack up these points. Let m be the function defined as m of x equals g of -2x times h of x. I want to find m prime of 2. Okay. All that fun stuff. Okay. Okay. So m prime of 2, so I need to find the derivative of this. So this, I can find the derivative of this and this. So this means look like a product rule. So m prime of x first before I plug in 2. So write down the first, derivative of the second, plus write down the second, derivative of the first. So when I find the derivative of this, I need to do chain rule. So derivative of the outside, keep the inside, times derivative of the inside. Bam. Okay, so I got all that stuff going on. Now I'm going to plug in 2, because that's what it asked for. So it's g of -2 times 2, which is -4. Let's put that right in. -4. H prime of 2 plus h of 2. And then g prime of -2 times 2 is -4 times -2. Okay, so now g of -4. That is the chart, right? Let's go back to our chart. G of -4 is 5. Cool. So we got 5 there. So this is 5. H prime of 2, we just did that up here. That's -1/3. Cool. Plus h of 2. So h of 2. H of 2. Right here. What is that? H of 2. We got to get h of 2 right there. So this is going to be, so this slope, so this line right here, I'm going to find 2. So this, the y-intercept is 0 and the slope is -1/3. So watch what I do. Watch what I do. No problem. So I know that the line there is y equals -1/3 x plus 0. How do I know that? Because the slope is -1/3 and the y-intercept is 0, because it intersects with 0. So now if I find 2 for the, so at 2 for the x, what is the y? That's what I want to know. I want to know the y value. So that's -2/3 is y. So that's -2/3. All right. And then g prime of 4, I go to the chart for that. So g prime of -4 is -1. Bam, right there. -1. Okay. So this is -1, and then I'm multiplying by -2 right there. So I can leave this because I solved it all out if I want to, or I can simplify a little bit, and this is negative times negative is positive. Positive times negative is negative. So that's going to be -9/3, which is -3. Bam. So that would be the final answer. M prime of 2 is -3. Cool. Almost done, almost done, almost done. All right, last part. Part D. So it's like IVT or MVT, right? So which one's it going to be? So I see G prime of C, so I'm thinking that's rate of change, so that looks like it's MVT on the closed interval -5 and -3. So I'm going to look here. So I got X and G of X. So -5 and -3. 10 and 2. Okay. So I need to justify my answer, looking at that. Okay. Looking good. All right. So you have to find between -5 and -3. That's the domain it gives you, right? So between -5 and -3. And I want to find the slope, in fact, is -4 at any one point, the instantaneous rate of change. So I'm finding this. Okay. So if I have the change in y, this is -8, right? And the change in x is +2, which means that the average rate of change, so the slope is -8/2, which is -4. Cool. So remember what the MVT is, and if you need to look it up, go ahead and look it up, is that the average rate of change between 2 points, like here, the average rate of change, the instantaneous rate of change at least one point on that interval has to be the same slope. So that's the MVT. So since G of X is differentiable, because it says that in the beginning, right? And therefore continuous, the average rate of change, which is this, on this interval is -4. So the instantaneous rate of change for this is also saying instantaneous rate of change, G prime of some C equals -4 on that interval for some C for some X value. You don't know what the X value is. It could be here, it could be here, you don't know. Some X value on that interval by the MVT. Cool. There it is. All right, ladies and germs, good work. Go ahead and redo any problems you didn't do right. Excellent job. I will see you